Welcome to Astronomy Daily. I'm your host, Anna, and I'm thrilled you're joining us for another exciting dive into the cosmos. Today, we'll be exploring the recent challenges faced by some ambitious spacecraft, uncovering surprising new discoveries about our very own Milky Way galaxy, and discussing a potential hidden family of asteroids that might be sharing Venus's orbit. Plus, we'll take a look ahead at what promises to be a very busy week for space launches around the globe. Stay with us. First up, let's talk about the challenges of lunar exploration. Japanese company Ispace has announced that it believes its second lunar lander mission, named Resilience, crashed due to problems with its laser rangefinder. This crucial piece of equipment is designed to determine altitude during descent, but it reportedly suffered a hardware issue. During a press briefing, company executives explained that the laser rangefinder, meant to provide the first altitude data at 3 kilometers above the surface, didn't give its initial measurement until the lander was less than 900 meters high. By then, the spacecraft was traveling much faster than planned, reaching 66 meters per second compared to the intended 44 meters per second. The last telemetry from the lander, at an altitude of 192 meters, still showed it descending rapidly at 42 meters per second. Images later released by NASA's Lunar Reconnaissance Orbiter show a 16-meter-wide crater, marking the probable crash site. Ispace's Executive Vice President, Yoshitsugu Hitachi, clarified that this incident was different from their first mission in 2023, which failed due to a software error. While the software on Resilience worked as intended, the laser rangefinder was a different model, sourced from a new, unnamed supplier. Investigations ruled out improper installation, leading the company to conclude the unit's performance simply degraded. Several factors could have caused this, including lunar surface conditions, reduced laser power, or even effects from the space environment like vacuum and radiation. Looking ahead, Ispace is taking significant steps to prevent future issues. Chief Technology Officer Ryo Ujiya stated they will enhance testing for the laser rangefinder and related sensors to better simulate high-speed and low reflectivity conditions. They're also considering using a different, flight-proven laser rangefinder and augmenting it with other sensors like LiDAR or cameras for more robust navigation. These efforts will be supported by a new external review board, including former engineers from NASA and the Japanese Space Agency, JAXA. Despite the setbacks, Ispace remains committed, with CEO Takeshi Hakamada emphasizing their resolve to keep improving and moving forward with their next missions, both still scheduled for 2027. Moving on, let's turn our attention to Europe, where the exploration company recently faced a setback with its Mission Possible test vehicle. This European company, which aims to develop orbital spacecraft for cargo and eventually human transport, achieved a partial success and a partial failure in its latest test flight. The vehicle powered up and flew successfully in orbit before making a controlled re-entry into Earth's atmosphere. Crucially, it managed to re-establish communication after the blackout period, suggesting it navigated the most thermally challenging part of re-entry effectively. However, the company lost contact with the spacecraft just a few minutes before its planned touchdown in the ocean. In a candid update, the exploration company indicated that the most likely culprit was an issue with the deployment of its parachutes, which were designed to deploy at specific velocities during descent. This demonstration vehicle, measuring 2.5 meters in diameter, aimed to test 4 key areas: structural performance in orbit, surviving re-entry, autonomous navigation, and recovery in real-world conditions. It only clearly failed in this final critical task of recovering the vehicle. Despite this challenge, the company's transparent and rapid communication, acknowledging the partial failure within hours of the launch, is quite refreshing in the space industry. The Mission Possible vehicle was developed at a relatively low cost of about $20 million in just 2.5 years, demonstrating the company's aggressive timeline and commitment. While it's possible the exploration company might conduct another subscale demonstration, this mission represents a significant step forward for Europe's commercial space sector, which has historically lagged behind the US and China. The ability to launch a fairly large vehicle and bring it back through Earth's atmosphere less than 4 years after the company's founding is a credible and promising start. They are now focused on developing their full-size Nix cargo spacecraft, with a potential flight as early as 2028. Now let's shift our gaze closer to home, within our own cosmic neighborhood. Astronomers have recently developed a groundbreaking new method for accurately mapping the outer gas disk of the Milky Way, and what they've found is quite surprising. It turns out our galaxy's structure is far more complex than previously thought, complete with what they describe as flocculent or tufty-looking gas clouds. This innovative approach, pioneered by Sukanya Chakrabarty of the University of Alabama and Peter Craig from MSU, relies on determining the precise distances to very young stars within the outer disk. They leverage data from the European Space Agency's Gaia satellite, which has meticulously measured the brightness, positions, motions, and crucially, the distances to nearly 2 billion Milky Way stars. As Chakrabarty emphasized, distance is one of the most fundamental things you can measure in the universe. Unless you know distances, you can't map anything. This is a significant departure from traditional mapping methods that use kinematic distances, which assume a model for the galaxy's velocity fields. These older methods can be imprecise, especially for gas clouds, which appear much fleecier and more disturbed than the smoother patterns seen in stars. To overcome these inaccuracies, the team used a clever pattern matching technique. They observed that the spiral structure in the gas clouds of nearby galaxies closely mirrors the structure of young stars, less than 400 million years old, which are born from these gas clouds. By pairing young stars with known locations to nearby clumps of gas, they created a new map that isn't dependent on the problematic kinematic assumptions. For highly accurate distance markers, they relied on Cepheid variable stars, which pulsate with a regular rhythm, allowing astronomers to calculate incredibly precise distances. The results are transforming our understanding. Craig noted that their new maps nicely demonstrate that the spiral structure in the gas disk of the Milky Way is highly flocculent, and that the overall structure of the disk is complex. This technique, combining pattern matching with accurate stellar distances, promises to significantly improve our understanding of the prevalence and shapes of the clouds in the hydrogen disk. Beyond that, these more accurate maps can enhance three-dimensional dust maps of the entire galaxy and help astronomers identify disturbances within the disk, such as interactions with nearby dwarf galaxies or even the presence of dark matter. It's a truly exciting development that paints an even more intricate picture of our home galaxy. Moving from the intricate patterns within our own Milky Way, let's turn our attention to an exciting discovery much closer to home, right in our solar system. Astronomers are currently delving into a little-known and largely unseen group of asteroids that quietly share Venus's orbit around the Sun. These fascinating space rocks, dubbed Venus Co-orbital asteroids, might be far more numerous than we ever imagined. To date, only about 20 of these unique asteroids have been confirmed. However, a new study led by Valerio Caruba from São Paulo State University in Brazil suggests that hundreds more could be lurking just out of sight. Caruba excitingly compared this potential discovery to discovering a continent you didn't know existed. The reason so few have been found until now is their elusiveness. They appear close to the Sun in our sky, making them difficult for ground-based telescopes to spot, and their rapid movement adds to the tracking challenge. To investigate this hidden population, Caruba's team ran extensive computer simulations, modeling the orbits of hundreds of hypothetical Venus co-orbital asteroids over a staggering 36,000 years into the future. They found that many of these objects could remain gravitationally bound to Venus's orbit for an average of about 12,000 years. Interestingly, their orbits appeared chaotic, meaning small shifts over long periods could eventually push them onto different paths, including some that might bring them closer to Earth. However, there's no need for alarm. Experts, including astronomer Scott Shepard from the Carnegie Institution for Science, emphasize that none of the known asteroids pose an immediate threat, and the timescales involved span many thousands of years. The likelihood of one colliding with Earth anytime soon is extremely low. Despite the low risk, understanding these objects is crucial for building a more complete picture of near-Earth space. Because they're so hard to spot from Earth, the team also explored new detection methods. Their simulations suggest that a spacecraft orbiting closer to Venus would have a much better chance, and the newly commissioned Vera C. Rubin Observatory, though not specifically designed for the inner solar system, could potentially catch some of these hidden asteroids during its special twilight observing campaigns. Further into the future, a proposed mission concept called Crown envisions a fleet of small spacecraft near Venus, specifically designed for this search. These efforts promise to unveil many more of these dynamically intriguing objects, adding another layer to our understanding of the solar system's diverse inhabitants. From hidden asteroids to perplexing planets, astronomers have been busy unraveling cosmic mysteries. And speaking of mysteries, scientists may have finally cracked the curious case of what are known as double hot Jupiters. These are rare exoplanet pairs found in binary star systems, with one scorching gas giant orbiting each of the twin stars. This arrangement has long puzzled scientists, seeming to defy our understanding of how planets form. But now, a team of astronomers believes they have the key to this celestial puzzle, a process known as von Zippel-Lidov-Kozai, or ZLK migration. Team leader and Yale University astronomer Milena Rice describes it as a dance of sorts. Essentially, in a binary star system, the gravitational influence of the second star can significantly shape and warp the orbits of planets, causing them to migrate inward towards their parent stars. The researchers propose that this mechanism leads to a mirrored migration process, resulting in both stars in the binary system ending up with their own hot Jupiter. To reach this conclusion, Rice and her colleagues performed numerous simulations of binary stars with two planets, using powerful computing clusters and data from sources like NASA's Exoplanet Archive and the European Space Agency's Gaia mission. The unintended yet exciting consequence of this research is that it makes our planet formation models a whole lot more interesting. We typically expect giant planets to form much further away from their host stars, which is precisely why hot Jupiters, especially pairs of them, have been such a captivating subject of study. For future discoveries, the team suggests revisiting binary systems where just one hot Jupiter has already been found. The crucial factor, however, is that these parent stars need to have a moderate separation, not too close and not too far apart, just the right distance for this gravitational dance to unfold. Next up, the Global Launch Manifest continues to be as busy as ever as we approach the halfway point of 2025. This week, we're looking at a packed schedule, highlighted by multiple SpaceX Falcon 9 missions, including a significant private crewed flight to the International Space Station. First up, Axiom Space aims to return crew to the ISS with its fourth private mission, AX-4, launching today if all goes according to plan from Florida. Commanding this flight is Peggy Whitson, a former NASA astronaut, making this her second commercial mission and further extending her record for the longest cumulative time in space by an American. Joining her are Shubhanshu Shukla from India and mission specialists Sławosz Uznański-Wisniewski of Poland and Tibor Kapu of Hungary, all making their first space flights and marking significant milestones for their nations. This mission also debuts Crew Dragon C213, the final capsule ever manufactured, completing SpaceX's fleet. The Falcon 9 booster will attempt a return-to-launch site landing. Beyond the crewed mission, SpaceX is maintaining its impressive pace with 3 Starlink satellite deployments also on the docket this week. 2 Falcon 9 flights will launch from Cape Canaveral carrying Starlink V2 mini satellites into low Earth orbit, while the third lifts off from Vandenberg Space Force Base in California. These launches underscore SpaceX's aggressive goal of completing 170 orbital flights this year. Elsewhere on the launch pad, Rocket Lab aims to continue its record cadence with the 67th Electron mission, Symphony in the Stars, from New Zealand. Slightly delayed for checkouts, this confidential commercial payload is set for a 650-kilometer orbit. Blue Origin also has its 5th New Shepard suborbital flight of 2025 NS-33, expected to carry a crew of 6 passengers just above the Kármán line for a brief period of microgravity after being scrubbed last weekend. And finally, a momentous launch marks the end of an era, the 50th and final mission for the Japanese H-2A rocket. This swan song flight, delayed due to an electrical issue, will carry the GOSAT Geo-Water-Earth Observation payload from the Tanegashima Space Center. This satellite is designed to monitor greenhouse gases and measure water on Earth's surface and in the atmosphere. The H-2A, with an impressive track record, is being phased out in favor of its successor, the H-3 family. And with that news, we wrap up today's episode of Astronomy Daily, where we explored everything from lunar lander challenges and a European spacecraft's re-entry setback, to the clumpy nature of our Milky Way and the hidden asteroids of Venus, plus the fascinating dance of double hot Jupiters, and a look at the busy week ahead for space launches. Thank you for joining us. I'm Anna, your host, and I hope you enjoyed this dive into the cosmos. Remember, you can visit astronomydaily.io to catch up on all the latest space and astronomy news with our constantly updating newsfeed and listen to all our back episodes. Subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. We'll see you again tomorrow. In the meantime, keep looking up.